This is Barry Hashimoto, and this is just a very brief introduction to my final project for CS50. The motivation of the project is that when faced with missing data, the researcher building an ML pipeline must either impute it or listwise delete it before building a model. The missing data has to be handled in some fashion. But should imputation be performed before splitting the data into training, validation, and testing sets, or afterwards and separately on each set so as to prevent the various sets from learning correlations in one another? Now, the received wisdom in some recent research is that post-split imputation is always best practice. A strict division between the sets must be maintained, and pre-split division leads to overconfidence. I don't have time to visit thoroughly all of the slides in this deck, so I will put them in the final project package for you to check out. But I want to briefly mention that I wrote analyze.r and simulate.r as two R scripts executable at the terminal with a command as simple as this, which can serve as the kernel for a larger Monte Carlo study to help answer these questions. And I think the code has a number of features that makes it attractive. It's fairly fast given the computational intensity of what's going on here. Now, the preliminary findings can be seen in a single plot that's saved from a run of analyze.r at the terminal. And they are that pre-split imputation does yield overconfident machine learning predictions. And we can see that down in the bottom right pane, but only when y is balanced. We see no overconfidence, i.e. the green and red lines are fairly close to 0 when y is highly imbalanced. And furthermore, listwise deletion is a surprisingly innocuous strategy for handling missing data when y is imbalanced.